Do you know the most important concept of this calculus is this area under the curve part? Here, fx is minus x squared plus 2x plus 3, whose graph is already given to us, and we have to find the integral in the first part. Integral that we can directly calculate, it's indefinite integral, but later they said also find the area of the shaded region. What's that? This gray region is to be calculated, but if you observe carefully, it starts from this x equals to 1 and ends at x equals to 2. So within this range, under this parabola with the x-axis. See that? So basically, in the second part, we have to find the area of the shaded region, which is nothing but area under this fx and x-axis from x equals to 1 to x equals to 2. So we can use our formula for area under the curve to get the answer. Okay, so this value, first let's calculate the indefinite integral, means the first part. So answer to the first part is, we have to integrate this negative x squared plus 2x plus 3. So we will do the term by term integral. Okay, so I'm going to use the formula which is given by integration of x raised to the power n dx is given by increase one power x to the power n plus 1 over n plus 1 plus c. This is the integral formula for x raised to the power n, but remember that n value must not be equal to 1. This formula will work if n is not equal to minus 1 only. Okay, now let's get back to the problem. Here it says we have to integrate this negative x squared. So term by term integration gives me negative as it is. Increase one power of x gives me x raised to the power 2 plus 1, which is 3 by same number 3. Then plus 2 as it is. X raised to the power 1 is given in the problem. We have to increase one power, that will give you 2 power divided by the same number. Then for 3, it's a constant number, so its integral is 3x simply. 3x plus c. So this is our answer to the first part. You can simplify it further, which gives me negative x cubed divided by 3 plus 2 cancelled, which gives x squared plus 3x plus c. Okay, this is my answer for the first part. Now in the second part they said find the area under the curve. So area under the curve fx start with the x-axis starting from x equals to 1 to x equals to 2 will be given by integral limits what 1 to 2 for the fx dx. Yes, what is the value of fx here? It is given by negative of x squared plus 2x plus 3 dx. But this time we have the limits also. That's the difference between first and the second part. In the first we had indefinite integral. We got the answer in terms of c. In the second part we have to solve this definite integral. Now here what you can do. Since calculator is not allowed, either you can calculate these values again and then substitute upper limit minus lower limit, or you can use the result from the first. We already have this result, right? We already have the integral part. So just substitute. Let me write it first. We get negative of x raised to the power 3 by 3 plus x squared plus 3x. You don't need constant of integration if you are solving definite integral. Okay, so I'm not writing plus c here. Even if you write it, you will get the same answer after that. So put upper limit, means everywhere in place of x substitute 2. Okay, so that gives me negative of 2 cubed divided by 3 plus 2 squared plus 3 times 2. After doing this, all you have to do is take a negative sign and substitute the 1 everywhere, which is the lower limit in the problem. It gives me negative 1 cubed divided by 3 plus 1 squared plus 3 times 1. Now, if you simplify it, means you just have to calculate the value and you will get your answer. So this value comes out as 7 by 3 with a negative plus 6, and overall What's the answer here? 18 minus 7 means 11 by 3 square units is the area. Okay, that's the answer for the problem. Some students feel difficulty in applying the concepts to the question. Sometimes they get stuck. So I'm going to tell you how to apply those concepts in the questions. I'll make it very easy for you. So if you are in middle year program, IBDP, MAI, HL, SL, MAA, HL, SL, AP Calculus, ABBC or any engineering math course, feel free to connect with us. You can contact us using this WhatsApp number or you can call us using this. You can also scan this QR code with WhatsApp to get connected with us. You can join our courses with flexible timings and one-on-one or group sessions are available or custom exam preparation where either you can choose for the full year course or few classes for your exam preparation. So scan the code, book your free demo today.